The United States Coast Guard have prepared this video about federal regulations on boat capacity and flotation. The purpose of this video is to show how one particular boat is measured and tested. All boats are slightly different. This video does not give you the exact information for your boat. It familiarizes you with some of the Coast Guard's requirements and shows you how the Coast Guard's testing contractor analyzes a boat. As a boat builder, you are required to comply with federal regulations and safety standards that apply to your products. These regulations and safety standards for recreational boats are covered in Title 33, Code of Federal Regulations, and in the American Boat and Yacht Council, ABYC book, Rules and Regulations for Recreational Craft. This four-part video addresses only a portion of these federal requirements. We will study safe loading and level flotation safety standards that apply to outboard-powered monohull boats less than 20 feet in length. The first part of this video demonstrates how to measure and mark a boat for testing. The second part illustrates how the values displayed in the USCG maximum capacities label are determined. This is the safe loading portion of the tape. The third part depicts testing methods for determining compliance with the level flotation safety standard. Finally, the fourth part provides a brief overview of the safe loading and flotation requirements for some other styles of boats that are not covered in this video. Before proceeding, we should define a few terms. 1. Maximum weight capacity. This is the maximum weight that the boat is intended to carry and is displayed on the United States Coast Guard Maximum Capacities label. It is the total weight of the people, motor, and gear that the boat can safely handle. Number 2. Maximum person's weight. This weight also appears on the Maximum Capacities label and is the total weight of people that the boat can safely carry. Maximum person's weight is derived from the maximum weight capacity just discussed. 3. Maximum persons. This is the maximum integer or whole number of persons the boat can safely carry. It is derived from the maximum person's weight and is displayed on the capacity label. Number 4. Motor, control, and battery weight. This is the government's mandated weight of the outboard engine, its controls, full portable fuel tank, and battery. You can find these weights in Title 33, Code of Federal Regulations. You are required to use these weights for calculations and testing, regardless of the actual weight on your boat. Number 5. Gear weight. After you have determined the maximum weight capacity of your boat, you will subtract the weight of the motor, battery, full portable fuel tank, controls, and the person's weight. Whatever remains is called gear weight. Number 6. Submerged weight. The dry weight minus the buoyancy force. This will be illustrated as follows. First, we will demonstrate the difference between a dry weight and a submerged weight. As you can see by the scale, the dry weight of these pig iron ingots is 535 pounds. Now, with the weight submerged, the scale shows a weight of 461 pounds. If we multiply the value of the submerged weight by a factor of 1.16, we find that we get 535 pounds, or the dry weight. The factor of 1.16 is for iron. Other factors for specific materials are shown on this table. By multiplying the submerged weight by the material factor shown here, you can find the equivalent dry weight to use for testing. Number 7. Reference areas. The forward and aftmost 2 feet of the top surface of the hull or deck. Number 8. Reference depth. The minimum distance between the submerged reference area and the surface of the water measured at the center line of the boat. Now, in Part 1 of the video, we will measure and mark 3 areas on the boat. These areas are referred to in the testing of the boat. The areas are, number 1, the middle 40% passenger carrying area. Number 2, the 70% areas of the interior port and starboard sides of the boat, and number 3, the fore and aft reference areas. These marked areas are also used in Part 3 of the video for level flotation testing. First, we must find the length of the passenger carrying area. This is the area in which a person can sit or stand while the boat is in normal operation. These builders have chosen a seated position at each end of the boat where a person might choose to sit and still have handholds for security. As a builder, use your own judgment to set the boundaries of the passenger carrying area. Now make a measurement of the total length of the passenger carrying area. Find the mid-length of this area by dividing the length by 2, and mark the mid-length on the boat. The length of our passenger carrying area is 138 inches. Dividing this number by 2 gives us 69 inches. The regulations allow you to put your test weights in the boat in such a way that the center of gravity of the weights used for the level flotation test will remain in a box area that is 40% of the total passenger carrying area. So let's find this box. To determine the length of the 40% box, take the length of the passenger carrying area and multiply by 40%, or 0.4, then divide by 2. This is the distance you must mark equally forward and aft to the midpoint of the passenger carrying area. Let us quickly review the formula using the measurement from our test boat. The length of the passenger carrying area is 138 inches. Multiplying this number by 40%, or 0.4, gives us 55.2. Dividing 55.2 by 2 gives 27.6 inches. Therefore, measure 27.6 inches forward and aft of the midpoint of the passenger carrying area to find the two ends of the 40% box. Now measure the width of the passenger carrying area, then multiply the width by 40% and divide by 2. You should mark this distance equally on both sides of the boat center line. For our test boat, the width of the passenger carrying area was taken at the cockpit deck level. For other boat designs, the location of this measurement may be different. Let us review our calculations. The width of the passenger carrying area is 65 inches. Multiplying by 40% gives us 26 inches. Dividing 26 by 2 gives 13 inches, which is marked on each side of the boat center line. Now tape an outline of the 40% box. During the level flotation testing, the center of gravity of the test weights must be inside this rectangular box, which represents 40% of the passenger carrying area. Another part of the level flotation test checks the stability of the swamped boat. This test requires the center of gravity of test weights be placed within narrow strips. The strips, which are centered at the mid-length of the passenger carrying area and located along the interior sides of the boat, are 6 inches wide and 70% of the length of the passenger carrying area. Next, mark the so-called reference areas by measuring 2 feet aft and forward, respectively, from the bow and the stern. Using a strip of tape across the boat, mark these areas for your boat. Now for part 2 of the video, determining safe loading values. First, we will determine how much weight we can load into our test boat without water coming aboard. If you designed your boat on a computer or have lines drawings for your boat, this number can be calculated. For this boat, we have neither, and will determine this weight by testing a completed boat. In preparation for this test, be sure that the drain plug is in. Only one hole, not to exceed 3 inches, is allowed in the motor well for motor and control cables. If your boat has cockpit drains with flapper valves, these are assumed to be watertight and can be sealed with tape also. To determine the maximum weight capacity, load weights into the boat until water is about to downflood or come into the boat. For our test boat, this occurred when the water at the stern was just about ready to enter the boat, and when the forwardmost point of the boat, or the bow, was just level with the water. To achieve these conditions, we loaded and carefully positioned 6,750 pounds of weight in our test boat. Permanent fuel tanks are supposed to be full for this test. However, for safety reasons, fuel is not being used for this test. We can simulate the effect of a full fuel tank by using some water in the tank to provide an equivalent flotation, or we can use weights placed over the fuel tank to simulate fuel weight. In either case, if you do not use fuel, the results will not be exact. If the flotation tests for your boat are close to the limit, you want to be sure to contact the U.S. Coast Guard to review the actions you have taken. The maximum weight capacity, which appears on the capacity label, cannot exceed 1/5 of the total weight loaded into the boat for this test. Therefore, the maximum weight capacity for our test boat is 1,350 pounds, or 6,750 pounds divided by 5. To determine the maximum person's weight, subtract the weight of the outboard motor, battery, controls, and full portable fuel tank from the maximum weight capacity just determined. Remember, these weights are mandated in 33 CFR Part 183, Table 4. The remainder is the maximum person's weight in pounds that the boat can safely carry. There is a formula to determine the number of persons for your capacity plate. This formula has been well proven over decades of use. To calculate the integer, or whole number of persons for your capacity label, add 32 pounds to the maximum person's weight and then divide by 141. If the number is not a whole number, round up if the fraction is 0.5 or greater, or round down if it is less than 0.5. Now for the actual calculation of the maximum person's weight and maximum person's number. The maximum horsepower allowed by federal regulations for our test boat is 90. Entering Table 4, Title 33, Code of Federal Regulations, we see the weight of the motor, controls, battery, and full portable fuel tank is 550 pounds. For our test boat, we previously determined that our maximum weight capacity was 1,350 pounds. Subtracting 550 pounds of the 90 horsepower engine and its controls from the maximum weight capacity leaves 800 pounds for the maximum person's weight. For this calculation, we add 32 pounds to the person's weight of 800 pounds and divide by 141. The answer is 5.9. This means the calculation allows for 5.9 persons. Since the fraction is 0.9, we can round up to 6 persons. This is part 3 of the video, dealing with the level flotation safety standard. Our next test is the level flotation test with person's weight. According to the regulations, the submerged weight to represent the people in the boat for this test is determined as follows. Of the 800 pounds permitted, we must use test weights that equal 1/2 of the first 550 pounds of our person's capacity, and of the remaining 250 pounds, the submerged weight must be 12.5% of the dry weight. So 1/2 of 550 pounds is 275 pounds submerged weight. Multiply the other remaining 250 pounds by 0.125 to get 31 pounds of weight. Add 275 pounds and 31 to get the required submerged weight for this test of 306 pounds. Therefore, to calculate the dry weight of iron used for this test, we multiply the submerged test weight by 1.16, the iron conversion factor. This says that a dry weight of 355 pounds of iron will yield the required 306 pounds when submerged, which is referred to as the person's weight in the following tests. Next, we place the center of gravity of the 355 pounds in the 40% passenger area that we marked up previously. Then we put weights for the battery, outboard motor, and controls in their normal operating positions. If gear weight is to be included, we would have divided the gear weight by 4 and included this amount in the equation. However, our test boat has no gear weight. For safety reasons, we did not fill the permanent fuel tank with gasoline as required by the Code of Federal Regulations. Instead, we calculated the fuel weight by multiplying the fuel tank capacity in gallons by 6 pounds per gallon. In this test, we have simulated the fuel weight by using a specific amount of water in place of fuel. For the level flotation test, any air chambers that are integral with the hull are punctured or flooded. The goal is to get any trapped air out of the hull so that it is the foam that is supporting the submerged boat. If air chambers that are not integral with the hull are used for flotation, then the 2 largest chambers are punctured or flooded also. In this boat, there are no air chambers, but we have drilled holes in the decks and other structures to allow randomly trapped air to escape after the boat is swamped. We now leave it to soak for 18 hours. Successfully passing this test means no part of the reference area is more than 6 inches below the surface of the water, and that the boat's heel angle is less than 10 degrees. You may adjust the weights loaded in the 40% passenger carrying area box to help the boat pass, provided that the center of gravity of the weights remain within the 40% box. Our boat is heeling less than 10 degrees, and the reference area is above the water at the center line of the boat, so the boat passes the test. Any point of the reference area, measured at the center line of the boat, could have been up to 6 inches below the water surface, and the boat would have still passed. That is, the reference depth can be up to 6 inches. Next, for the swamp stability test, we remove 1/2 of the person's weight from the 40% area box and move the remaining weights to the red area marked along the starboard side of the boat. With the boat flooded, the remaining weights, approximately 178 pounds, must be placed so their center of gravity is within the area marked by the red tape. The weights have to be uniformly distributed over a length that is at least 30% of the length of the passenger carrying area. In addition, the weights must be placed so that their center of gravity is 4 inches off the floor and no farther than 6 inches from the side of the passenger carrying area. With the weights in place, the boat should not heel more than 30 degrees, and the reference depth cannot be more than 12 inches. Our test boat exceeds the 30-degree heel angle limit allowed by the regulations and fails this test. Therefore, flotation foam will have to be rearranged or additional foam put into the boat. We now repeat this test on the port side of the boat, which passes the test. This boat graphically shows a successful test and a test failure. This boat must be modified so that it passes the test on each side. For the next test, we remove all the rest of the person's weight from the boat. This is the level flotation test without any person's weight. In the swamp condition, the boat should not heel more than 10 degrees, and the reference depth cannot be greater than 6 inches at the boat's center line. Our boat passes this test. This completes the flotation test for this boat. Testing can be done in any order. These professionals found this sequence to work best. Test your prototype boat to be sure it will pass these tests. all production boats must also pass these tests. For good measure, most builders will add a little extra flotation to ensure that any production irregularities do not result in a boat that will not pass the test. Part 4 of this video takes a quick look at safe loading and flotation requirements for recreational boats that differ in design from the boat just tested. Some notable differences in these boats, as the federal requirements apply, are noted. For rowboats and outboard-powered boats with 2 horsepower or less, air chambers may be used for flotation, including air chambers integral with the hull. Other significant differences include the formulas for calculating maximum weight capacity and maximum person's weight. Calculations for weights to be used in the level flotation test are also different. For boats that have a person's capacity less than 550 pounds, you need to perform an additional test to determine the maximum weight capacity of the boat. This test requires the weights be added and distributed along the side of the boat until water begins to come in. Stern drive and inboard-powered boats have to comply with basic flotation, not level flotation. Basic flotation requires that when loaded and swamped, any part of the boat be above the surface of the water. For that test, the maximum weight capacity is calculated differently than described in the video for outboard boats. The next 2 boats illustrate the marked-out 40% passenger area box and 70% strips for boats that differ in design from our test boat. You are encouraged to take advantage of the Coast Guard's Voluntary Compliance Test Program. At this time, it is offered free to manufacturers who volunteer their boats for testing. The Coast Guard will arrange to pick up your boat, test it, provide a test report, and return the boat to you at no charge. For more information, contact the U.S. Coast Guard Recreational Boat Product Assurance Division at 202-267-0984. The information in this video is only an overview of the federal requirements for safe loading and level flotation. For in-depth documentation of these and other safety standards for recreational boats, please refer to Title 33, Code of Federal Regulations, or ABYC's Rules and Regulations for Recreational Craft. You are encouraged to contact ABYC for information about our standards, to request technical help with your boats and testing, or for more information about the Council and its committees. The American Boat and Yacht Council is an association of marine industry professionals working to make boats and marine products safer. ABYC began in 1954 as a non-profit public service membership organization. The ABYC now numbers over 3,500 marine professionals, corporations, and associations worldwide. ABYC publishes a book of all the standards that apply to boat builders. The ABYC book, Standards and Recommended Practices for Small Craft, is the product of a consensus of representatives of government, industry, and public sectors. It is a guide to aid the manufacturer in the design, construction, equipage, and maintenance of small craft. The ABYC work product is a book of standards that is far more extensive and complete than the limited federal requirements. Approximately 80% of boats built today are manufactured by ABYC members. These companies work with ABYC and the U.S. Coast Guard to improve boating safety.